everyone, this is Sandeep Desai from Asha Tutorial. So let us take here first example. Suppose we have to take a product of 2.314 multiplied by we have suppose 1.056, and this we want to do. Now this product we can't able to find out just simply. So here we can use log table. So we know that when there are product of two numbers and when we take log of that, we just need to add the log of those numbers. This is a product rule that we have to use over here. So if I take log of, suppose this product of two numbers 314 into 1.056, then I have to add the log of 2.314. In that I have to add log of 1.056. So how do we find log of this number? That we will discuss in our previous lecture. As this is a one digit, single digit number, so its characteristic value we can write that is 0. Then let us write decimal point. And what now we have to do? Find the log of 23 in first column and mean difference in fourth column. Here we have to find the log of 23. Here there is a 23 in first column, which is 36 and the mean difference that is in fourth column. Here you see in fourth column it is 7, which we are supposed to add in this. We get 3643. So here we can write that is 36443. This is the log of 2.314. Now let us add the log of 1.056 in this. So again this is a one digit number, so its characteristic value is 0. Then let me write decimal point, and we have to find log of 10 in 5 and 6. So what is log of 10 in 5 and 6? See here, this is 10 and we have to find log of 10 in fifth column, which is 0 to 1 2, and mean difference in sixth column. So here it is 25. So when I add 25 in 0 to 1 2, how much do I get? 0 to 3 7. So let's take that 0 2 3 7, and when I add these two, I'll get this number 3 and 7, that is 10, carry 1, this is 4 and 4, that is 8, then 2 and 6, that is again 8, and 0 and 3, that is 3, and decimal point, and 0 plus 0 is 0. Now let's say this is not our final answer. This we got, that is by adding the log of these two numbers. To find the answer, we have to take anti-logarithm, anti-log of this number. And how do we find anti-log of this number? See the anti-log of first two digit which come after this decimal point in next two columns. So here we have to find anti-log of 0.38 in 8th column, and as here this is 0, so we are not supposed to worry about mean difference. So we have to find the anti-log of 0.38. Here there is 0.38, and in 8th column you see here in 8th column, if I go in 8th column, how much is the value of that we have? 2443. So this is the anti-log of 0.38 in 8th column. So let us write that. So here we write anti-log of 38 in 8, that is 2443. While deciding the decimal point position, just add 1 in this characteristic value. So 0 plus 1 is 1. That means as it is a positive 1, let's write this decimal point after one digit to the right. So our final answer of this product of two number we got, that is 2.443. Now let's take one more problem so that we understood it in better way. So let us take second problem. Suppose we want to find the answer of 35.8 into 94.24. This we want to find out by using log table. So as again here there is a product. So if I take log of this 35.8 into 94.24, so as per the product rule we have to add the log of 35.8 plus log of 94.24. So let's find the log of this. So here you see this is a two-digit number. So the characteristic value of this will be 1 as 2 minus 1. So characteristic value is 1. Then let us write decimal point and find the log of 35 in 8. Here you see the log of 35 in 8th column. How much it is? 5539 we have. Log of 35 in 8th column, that is 5539. 5539. Plus to that we have to find the log of 94 in 24. So 94 is again a two-digit number, so its characteristic value is again 1, then decimal point, and we have to find log of 94 in 2, and then I have to add the mean difference from 4th column. Remember 94 second column and 4th column mean difference. So let's go here. 94, this is 94. I have to find the log in second column, which is 9741, and mean difference from fourth column, which is 2. So if I add 2 here, I'll get 9743. 9743. 9743. Then add this 2. So if I add here this 2, how much I get? 9 plus 3, that is 12. Carry 1, then 5 plus 3, that is 8. This 7 plus 5, that is 12. Then this carry 1, this 10 plus 5, that is 15. Carry 1, and this 3, that is we get 3.5282. What we have to do of this? Let's find the anti-log of this number 3.5282. And while finding the anti-log, as I told you, we have to find anti-log of the two-digit number which comes after this decimal point. Means here we have to find anti-log of 0.52 in 8 and 2. Anti-log of 0.52 in 8 and 2. So here we have 0.52, right? And we have to find its anti-log in 8 and 2. So in 8th column, its value here we have, that is 3373. In second column we have mean difference, that is 2. So if I add in this 3373 this 2, we will get 3375. So here the answer is 3375. Now here you see where we put the decimal point. Here the characteristic value is 3. In that if I add 1, we get positive 4. So I have to write the decimal point after 4 digit. So 1, 2, 3, 4. That means here. So my answer of this product that I get, that is 3375. Else we do the another thing, that instead of adding 1 here, as we get anti-log of 0.52 in 82, that is 3375, right? So the one which we add generally here, instead of that, let me mark here decimal point after 1 digit, and whatever we get here this characteristic value, let me write it as power of 10. So this way also we can write the answer of this particular problem. Now let's take one more problem. 5.234, we have, suppose it is divided by 2.128. So we can do this with the help of log table. Now as here there is a ratio, there is a dividation. Here while using log table, when we want to solve this, we have to use quotient rule. As per quotient rule, we know that log of m by n, when we take log of m by n, there we do the subtraction of log of m and log of n. So log of m minus log of n. So this is quotient rule. So let's apply this to solve this problem. So here this log of 5.234 divided by 2.128. To solve this, we have to take log of 5.234 first of all. From that, we have to subtract the log of 2.128. So let's find the log of this number. Again, here you see, as this is a single digit number, so the characteristic value of that is 0 point. Then we have to find log of 52 in 3 and 4. In third column, that is 7185, and in fourth column its mean difference is 3. So when I add in this 7185 this 3, I'll get 7188. So here it is 7188. From that we have to subtract the log of 21 in 28. Here again the characteristic value is 0 as it is a single digit number. So let's see what is the log of 21 in 2 and 8. Where is 21? Here there is 21, and we have to find its log in second column, that is 3263, and mean difference in 8th column it is 16. So let's add this 16 here. So what I get? 3279. 3279. Here we have to subtract these two logs. So let's do that. Now let's do the subtraction of these two logs. Now we have to find the antilog of this 0.39 in 0 and 9. So let's do that. So where is 0.39? Here you see, here we have 0.39. We have to find its antilog in 0th column, which is 2455, and mean difference in 9th column, which is 5. So if I add that here, I will get that is 2460. So my final answer is here 2460. And where do I put the decimal point? Here you see the characteristic value is 0, in which if I add 1, that means I get positive 1. So let me write the decimal point after one digit. So my final answer here it is 2.460. I hope you understood this. Let's take one more example so you get better insight in solving such kind of problem. Let's divide the number 82.8 by 90.42, again by using log table. So how we do that? Here what we have to do? So let's first of all find log of 82.8. As it is a two-digit number, so I'll write its characteristic value is 1, because we subtract 1 from whatever be the number of digit we have before this decimal point. So the characteristic value is 1, and let's find the log of 82 in 8. So log of 82 in 8, so here there is 82, and the log of that in 8th column we have, that is 9180. 9180. From this we have to subtract the log of 90 in 42. Again here the characteristic value is 1, and let's find the log of 90 in 4th column and mean difference in 2nd column. So 90 in 4th and 2nd column. So you see there is a 90, and we have to find its log in 4th column, which is 9562, and mean difference in 2nd column, which is 1. It means we get that log is 9563. That is 9563. And we have to subtract these two logs. So let me do here the subtraction. This 0 minus 3, that doesn't get cancelled. So 10 minus 3 is 7. Then 8 minus 7, that is 1. Then here 11 minus 5 is 6. And 19 minus 10 is 9. Carry 1, and 1 minus this 2. 1 minus this 2, we get that is bar 1. So we have to find the antilog of 0.96 in 1 and 7 to find the correct answer. So let's do that. 0.96 is here, and its antilog in first column 9141, and mean difference we have to find from 7th column, which is 15. So if I add 15 here, we get that is 9156. So 9156. This is the antilog of 0.96 in 1 and 7. Now where we give the decimal point, you see here there is a bar 1. In this, when I add 1, that is minus 1 plus 1 is 0. So I will write the decimal point by writing like this, 0.9156, just before this number. So this is my answer of this particular problem. Now let's take some problems related with the power by using power rule. We know the power rule in logarithmic. As per this power rule, if you want to find out the a raised to m by using log table, if we take log of a raised to m, so that is equal to, we write m times log of a. Suppose we have number 2.31 and we are supposed to find out its fourth power. How do we do that? By using log table. It's very simple. Just by following this power rule, I can write, when I take log of this number, I will write it as 4 times log of 2.31. So I have to take log of this 23 in 1. Again you see the characteristic value here, we write that is 0 as it is a single digit number. So log of 23 in 1, what is that? Here we have 23 and its log in first column is 36, 36. So I'll write this is 36, 36. To this I'll multiply by 4. So if I multiply it by 4, how much do I get? This is 4 6 are 24, then 4 3 are 12, and this 2 is 14. 4 6 are 24 and 1 25, and this 4 3 are 12 and this 2 is 14. So it means we get this number after multiplying with the 4, that is 1.4544. We have to find antilog of this to find our final answer. So let us find the antilog of 0.45 in 44. So here there is 0.45 and we have to find antilog of that in fourth column, and let us add in that the mean difference from fourth column, which is 3. So here when I add 3 in this, I'll get 2847. 2847. 2847. So this is the antilog of 0.45 in 44. Then where do I mark the decimal point? Here you see the characteristic value is 1. Add in 1 that, so I'll get 2 as it is positive 2. So let me write the decimal point after the 2 digit. So my answer is here 28.47. Now as you understood how to do the multiplication, dividation, or taking power of certain numbers, let us solve one problem based on those rules by using log table. 6.63 into 10 raised to minus 34 into 2.99 into 10 raised to 8 divided by 5.5 into 10 raised to minus 7. How do we solve this problem with the help of log table? While solving such kind of problem with the log table, remember one thing: do the calculation of number separately and the calculation of power separately. So if I separately write the numbers first of all, that is 6.63 into 2.99 divided by this number is 5.5, and into this power collectively I will write as 10 raised to minus 34. Then here we have this is plus 8, and this minus 7, if I take in numerator, it becomes plus 7. So this power calculation we have to do it separately. Now to solve this particular product and dividation, let us use log table. So here, as there is multiplication of 6.63 and 2.99, first of all I will add the log of 6.63 in log of 2.99. Let's find their logs now. So let me write here their characteristic value. Those are how much we have? 0, as they are single digit number. Now let's find the log of 66 in 3. Log of 66 in third column, here we have, that is 8215. 8215. And then we have to find log of 29 in 9. Log of 29 in ninth column, that is 4757. 4757. If I add this two, how much do I get? Let's see. 7 plus 5, that is 12. Then this is 7. 7 plus 2 is 9. 8 plus 4, that is 12. So I'll get this is 1.2972. So this I get by adding the log of these two numbers. But remember, to this number we have the divided number, that is 5.5. It means from this number we have to subtract the log of 5.5. And how much it is there? We have the characteristic value of, that is 0. We have to find log of 55 in 0. Remember, if nothing is there, we have to find log of this number 55 in 0. So let's find that. So here there is 55 and log of 55 in 0 we have, that is 7404. So it is 7404. If I subtract this 2, let's see what we get. 2 minus 4, that means 12 minus 4, I get here it is 8, carry 1. 7 minus 1 is 6, then 9 minus 4, that is 5. This is again 12 minus 7, I get, that is 5, carry 1, and here I get 1 minus 1 is 0. So here, after adding the numbers, adding the logs and subtracting one log, I get this number. We have to find anti-log of this number now. Anti-log of 0.55 in 6 and 8. Let's do that. Anti-log of 0.55 in 6th column and mean difference in 8th column, that is 7. So how much we have? This is 3597 plus 7. So how much we get? That is 3604, right? 3604. 3604. And where do I put the decimal point? If I add 1 in this 0, I get positive 1. So just after one digit, I will write the decimal point. So after solving this bracket, definitely with the help of log table, I'll get this answer, that is 3.604. And next to that into, I will write this 10 raised to this 8 plus 7 is 15, and minus 34 plus 15, that gives me minus 19. Yes, so this is my answer of this particular problem. So this way we can able to find out the answers. Now suppose sometimes it is asked to find out the cube root or fourth power root of certain numbers. Suppose we have here one number, that is 125, and if you are asked to find out cube root of this, now already we know the cube root of 125 is 5, but with the log table, do we get the same? Let's check. So cube root of 125, that means 125 raised to 1/3 we have. So by power rule, it is 1 by 3 times we have to take log of 125. Now 1 by 3 times, what is the characteristic value of 125? As it is a 3-digit number, so its characteristic value is 2. 3 minus 1, that is 2. And we have to find log of 12 in 5. So let's find the log of 12 in 5. Here there is 12, and in its 5th column we have its value is 0969. 0969. To this we have to divide by 3. So if I divide it here by 3, how much I get? Let's see. This is 0.3618, then remain 2, then 3 nines are 27, then 3 8s are 24, and again 3 9s are 27. next to that remains, but let me take here after decimal only up to 4 digit this number. This is not the answer. We have to find the antilog of this number. Let's find the antilog of 0.69 in 8 and 9. So let's do that. Here we have 0.69 and its antilog we have to find in 8th column and mean difference in 9th column, that is 10. So when I add 10 in this 4989, I'll get 4999. That means I can write this as 4999. And where do I put the decimal point? Just after one digit, because when I add 1 in this 0, I get positive 1. So I get the cube root of this 125 by using log table, that is 4.999, which definitely we can write as 5. So it means our answer is correct. So like this, we can take certain numbers of which we know the cube root or squares, or even we know the product of two numbers. So like that we take a number, and by using log table we can find their answers and we can cross check, so that uh, in using log table we will become more perfect. So I hope you understood how to use log table while solving the problems related with multiplication, division, their combination, and also to find powers and roots or cube roots, etc. Thank you.